Hi, everybody. It's Professor Mitchell. Today we are starting Chapter 9. This is the last chapter that we will cover in Math 1610, and this chapter is on hypothesis testing. So in this video, we will talk about the introduction to hypothesis testing, where we will identify the null and alternative hypotheses for an experiment with one population mean, distinguish between one- and two-tailed hypothesis tests and understand possible conclusions, and finally differentiate between type 1 and type 2 errors when performing a hypothesis test. So this is a slide that I added. It has an analogy that I really like. I did not make this up, though. This is a classic analogy for hypothesis testing. So a hypothesis test has many of the same elements as a criminal trial. It has a null hypothesis. The null hypothesis usually represents the status quo, what is the generally accepted belief. And in a criminal trial, that is that the defendant is innocent, right? Innocent until proven guilty. The alternative hypothesis is a challenge to the status quo. So somebody claims that something has changed or that the situation we're in is not like other situations that are more usual. And so in the case of a criminal trial, that would be the defendant is guilty. So the null hypothesis and the alternative hypothesis have to be opposite statements. Then we have in a hypothesis test something called the level of significance. In a criminal trial, the level of significance is the probability that an innocent person will be convicted. And in a criminal trial, that probability is supposed to be very, very low. That's kind of a cornerstone of our criminal justice system. The test statistic in a criminal trial is the evidence presented by the prosecution. So in a general hypothesis test, the test statistic is the evidence against the null hypothesis. And then finally, you will reach one of two conclusions. You will either reject the null hypothesis, and in a criminal trial, that would mean the defendant is found guilty, or you will fail to reject the null hypothesis. Now, that wording is really, really important. We never say accept the null hypothesis. Just like in a criminal trial, the jury never comes back and says we find the defendant innocent. And there's a really good reason for that. In a criminal trial, it is not the job of the defense to prove that the defendant is innocent. It is the job of the prosecutor to prove that the defendant is guilty. And either the prosecutor does that or they fail to do that. And so when we don't find strong enough evidence against the null hypothesis, we say we fail to reject the null hypothesis. All right. So, on this slide, we're talking a little bit more about null and alternative hypotheses. So how to identify the null and alternative hypothesis. The null hypothesis, which is denoted by H subscript 0, makes the assumption that nothing has changed, like I said earlier, the status quo, disagrees or opposes the research question. So the research question is usually a claim against the status quo. And I'm sorry about the typo. I don't think I can fix this because this looks like an image. And the null hypothesis, when you write it symbolically, will always include equality, either equals, less than or equal, or greater than or equal. Some books, including the book that I use for Math 1600, always puts an equal sign in the null hypothesis. So this depends on which book you're using, but your book uses either equals, less than or equal, or greater than or equal. The alternative hypothesis, which is denoted H subscript A, or sometimes H subscript 1, refuses or does not accept that nothing has changed, a challenge to the status quo. It's the research question to be investigated, and symbolically, it will never include equality. It will either be does not equal, less than, or greater than. So applying this last property, it is valid to see that the null hypothesis and the alternative hypothesis are opposite of each other and cannot be true at the same time. So there are three different types of situations. One is that the null hypothesis, I'm gonna start by talking about the alternative hypothesis, because often it's easier to state the alternative hypothesis first. So your alternative hypothesis might say does not equal, in which case your null would say equals. They have to be opposite. By the way, this is called a two-tailed test. We'll talk more about that later. The second situation is that the alternative hypothesis says greater than, in which case the null hypothesis would say less than or equal to. And the third situation is alternative hypothesis says less than, in which case the null hypothesis would say greater than or equal. So here's an example. A manufacturer advertises that their butane lighter average life expectancy is 5.5 years. A consumer group thinks that they do not last that long and wants to set up a hypothesis test. If mu denotes the average life expectancy in years of the butane lighter, what are the null and alternative hypotheses in this situation? So I recommend that you think about your alternative hypothesis first. That is a claim against the status quo or the generally accepted belief. And in this case, that's being made by the consumer group. The consumer group thinks they do not last 5.5 years, which means they believe they last less than that. So the alternative hypothesis would be that mu is less than 5.5, and therefore the null hypothesis has to be that mu is greater than or equal to 5.5. Here's another example. We want to test whether the mean time to failure of laboratory gloves used in the snobby section of a company, that's cute, is different from 9 months. What are the null and alternative hypotheses? Okay, so the claim being tested is that these gloves don't last 9 months. They last some other amount of time. Okay. So there's really no feeling about whether they last less time or more time. Maybe we've started buying gloves from a different manufacturer and we don't really know if they're better or worse. Okay. So in that case, this type of test would be appropriate. Since it says different from 9 months, that is a does not equal. So the hypothesis would be mu does not equal 9, and therefore the null hypothesis has to be that mu equals 9. All right, so next we come to one- and two-tailed hypothesis tests. The choice of which test to apply will depend upon the null and alternative hypotheses declared. One-tailed tests when the null and alternative hypotheses have a direction and will only recognize a difference if it is in that precise direction. So again, coming back to the three different sets of hypotheses you could have, a one-tailed test will happen when your alternative hypothesis contains a less than or a greater than. So just flashing back here. These two situations right here, number 1, number 2, would be one-tailed tests. This one right here would be a two-tailed test. So let's go back to that. A two-tailed test will allow the detection of a difference in either direction. So the example with the laboratory gloves, we're buying them from a new manufacturer. We don't know if they're better or worse. This test will detect if they're better, and it will also detect if they're worse. All right, in a charter school in Houston, it was stated that 6.6% of the students take the advanced placement exam. What kind of test should be used to ascertain if the percentage of the students in this school who take the placement exam is more than 6.6%? And they want us to state the null and alternative hypotheses. So the status quo belief is that 6.6% of the students take the AP exam, but now somebody's wondering if it's more than that. So the alternative hypothesis would be that this population proportion is greater than 6.6%. So notice, oh dear, little typo there. I did check this before I started, and I thought I found all the typos. Okay, that should be an A. All right. So the alternative hypothesis is that this looks actually like a letter, Greek letter rho. It kind of looks like a P. And to be honest, I cannot remember off the top of my head if your book uses P or rho for population proportion, but anyway, that's what it stands for. Okay. The alternative would be that that proportion is greater than 0.066, so we're writing it as a decimal. And then the null hypothesis has to be that the proportion is less than or equal to 0.066. What kind of test would this be? This would be a one-tail test because this is a greater than, it has direction. Specifically, it would be a right tail test. A right tail test has a greater than in that spot, and a left tail test has a less than in that spot. And again, if it had a not equals, it would be two-tailed. Okay, next example. A product analyst reports that the mean life of a particular diesel generator, the mean life of a particular diesel generator is not 123 months. State the null and alternative hypotheses. Well, this one should be pretty simple. So the analyst thinks that the mean life is not 123 months. That would make our alternative hypothesis does not equal. Mu does not equal 123, which means that the null has to be that mu equals 123. So this would be a two-tail test. Two-tailed test only happens when you have does not equal here. All right, next we come to differentiating between type 1 and type 2 errors when performing a hypothesis test. So there are 4 possible things that can happen with your hypothesis test. Not rejecting the null hypothesis when the null hypothesis is true. So that would be a good thing. That would mean that we reached the correct conclusion. And on the next slide, I'm going to relate this back to the criminal trial. However, it's also possible to reject the null hypothesis when the null hypothesis is true. So that would be an error, okay? Now, we do the best we can with the evidence that we have. So the types of errors that we're talking about now are not the types of errors that would lose you points on a statistics exam. But if you're doing statistics in real life, what you really have to consider is which type of error would be worse, and you can adjust your testing procedures accordingly. Next possible situation is that we don't reject the null hypothesis when the null hypothesis is false. That would also be a mistake, right? And finally, rejecting the null hypothesis actually false, that would be a good thing. That would be correct. So those situations are organized in this chart here. The first one, not rejecting the null hypothesis when the null hypothesis is true. That would be right here. Second one, rejecting the null hypothesis when the null hypothesis is true. That is called a type 1 error. Third one, not rejecting the null hypothesis when the null hypothesis is false. So if we don't reject the null hypothesis, I'm sorry, if the null hypothesis is false, then that means the alternative hypothesis is true. All right, and if we don't reject a false null hypothesis, that's called a type 2 error. If I could add one thing to this picture, this is what I would add, because this is kind of vague. This on top here should really say fail to reject the null hypothesis. And the second one, I guess, could say accept the alternative hypothesis. Okay. Hopefully that'll make it a little clearer. Okay. Oh, wait a minute. No, I'm sorry. It's a lot simpler than that. Okay. This would be that the null hypothesis is true, and the second one would be that the alternative hypothesis is true. There we go. Okay. All right, so let's see, get my mouse back here. Okay, I think I got it back. All right, so let's try this again. Not rejecting the null hypothesis when the null hypothesis is really false. So if the null hypothesis is false, that means the alternative is true. And if we don't reject the null hypothesis, that's a type 2 error. And finally, if we reject the null hypothesis and the null hypothesis is false, meaning alternative is true, then that's the correct decision. Okay, so in terms of a criminal trial, again, a type 1 error is, and here I'm using slightly different wording. I stole this from the Math 1600 PowerPoint. The mistake of rejecting the null hypothesis when it's actually true. So the analogous criminal trial situation is that the defendant is innocent. Remember, that was the null hypothesis. But if you reject the null hypothesis, that means you're finding the defendant guilty. Okay? So in the US criminal justice system, we try very hard to not make this mistake. Okay. And I have a little image that's going to come up here in a minute that kind of goes to that. However, a type 2 error is the mistake of failing to reject the null hypothesis when the null hypothesis is actually false. And that means that the defendant is guilty, but is found not guilty. So Benjamin Franklin said that it is better 100 guilty persons should escape than that one innocent person should suffer, is a maxim that has been long and generally approved. So what Benjamin Franklin is saying here is that in the criminal justice system, we don't want to make type 1 errors. We want that to be very, very, very unlikely, right? Because a guilty person escaping, that would be a type 2 error. An innocent person suffering would be a type 1 error. Okay? And that's why in a criminal trial, we say that the defendant should only be found guilty if the evidence proves their guilt beyond the shadow of a doubt. So we ask for really, really, really strong evidence to convict somebody of a crime. Okay, example, a car battery manufacturer is testing a lithium battery to see how long it can last. The null hypothesis is that the lithium battery can last at least 1,143 watt-hours per liter. The alternative hypothesis is that it lasts less than 1,143 watt-hours per liter. What is a type 2 error in this scenario? So again, a type 2 error is when you fail to reject a false null hypothesis. So if the null hypothesis is false, that means the alternative is true. And that means that the lithium battery lasts less than 1143 watt hours per liter, but they conclude that it lasts at least that long. So in other words, they would be selling a battery that does not last as long as maybe the packaging says it does, or that advertising says it does. So you'd have some angry consumers if they committed a type 2 error. They would be accused of false advertising. All right, determine the type 1 error given that the null hypothesis is the mean cost of a 12-pack of soda is $5.49. So a type 1 error is rejecting a true null hypothesis. So that would mean that the mean cost of the soda is actually $5.49, but we conclude that it's not. So you think the mean cost of a 12-pack of soda is not $5.49 when in fact it is. That would be a type 1 error. And that's the end of this first video on chapter 9.